So in lesson 510, we're going to be looking at similar figures and using our work with proportions from 5.9 to help solve for missing side lengths and solve for x in different situations. So the big idea is that ratios of lengths of similar geometric figures, so similar shapes, are equal, giving rise to many applications and proportions that we can set up. So the key thing here is that similar shapes are basically enlargements or reductions of another shape. So if I took any random shape and I just enlarged all the sides by, say, 5, so all the sides got multiplied by 5. If I set up the corresponding sides as ratios, they're going to be equal to each other. Okay, and then I'm going to be able to set up some proportions and cross multiply. So we're going to talk more about that in a second. So our two definitions, the ratio of similitude basically talks about what I just said, the ratio of the lengths of corresponding sides of two similar figures. Okay, so when you have similar figures, like if you take a look at these, this is just an enlargement of the other one because they're similar. If I set up ratios of corresponding sides, so the ones that match, when we say corresponding sides, the top to the top, the x to here, the 7 to this one, the bottom to the 15, those are your corresponding sides. They're all going to be in ratio. So you can already see this is not a perfect, nice number. This will be a decimal when we start looking at this. But let's say the bottom of this was 5 and this was 15. Well, then that's 3 times the size. Then all the other sides would also be 3 times the size. So this would be 21, and this would be 9, and this would be 3 times the size of that. So if they are similar figures, they are all going to be able to set up equal ratios like that. And that's what this next part says. So let's jump right in. We have two quadrilaterals, quad meaning 4. When you write a quad, right, there's 4. So a 4-sided shape, it's not a perfect shape like a square, a rectangle, a trapezoid. It's just a 4-sided shape. They tell you they're similar, which means we're allowed to set up equal ratios. They tell you the corresponding sides are parallel. Find the value of x. All right, so what we want to do is we want to set up some proportions like we had in 5.9, and we're going to cross multiply to find our missing sides. So we can kind of set up a sentence here. If x to 12.6 is the same as, so notice where I started. I'm comparing the two corresponding sides that has the variable because that's what I need to solve for. So x compares to 12.6. So if x to 12.6 is the same as 3 to 4.8, what is x? That's what I'm trying to figure out. That's basically the question here. X compares to 12.6 the same way that 3 compares to 4.8. So if I'm going to set that up, I'm going to say x compares to 12.6 the same way that 3 compares to 4.8. This relationship, this ratio is equal to this one. Okay, so once I've got this set up, all I have to do is cross multiply, and I can get my answer. So across here, 4.8x. When I multiply these, I get 37.8. All I got to do is solve this now, so I'm going to divide by 4.8. And x equals 7.875 centimeters. So again, match up your corresponding sides. Notice that I didn't use the 7 and I didn't use the 15. Why? Because the corresponding side to 7, I don't have any information on. The corresponding side to 15, I don't have any information on. So the only way that I can set this up and actually use the information to solve it is I have to find a pair. I have to find sides, corresponding sides that have a match. So I can take the relationship that's given to me between these two and relate it to the relationship between my variable and then its corresponding side. Over here, I don't have enough information. Over here, I don't have enough information. So I specifically had to choose to relate the variable to the tops because there was 2 numbers there. All right, sliding down. These are very common questions. using shadows, and we actually did this in 7th grade. So using shadows to estimate some heights. So we're going to use the measurements to find the height of the flagpole. So basically, if this was a word problem, they would say you have a 3-foot ruler that casts a 5-foot shadow at the same time a flagpole is casting a 72-foot shadow. So if this is happening at the same time, you can use these relationships to set up a proportion. These would be considered similar figures. Notice there's a dotted line that's just there to kind of show this is a shape, this is a triangle. But we're going to go ahead and relate the sides. So 5 compares to 72. The shadow compares to the shadow the same way the height compares to the height. So 5 compares to 72 the same way 3 compares to h. So notice I've got these two numbers which correspond to my ruler, and then these two numbers which correspond to my flagpole. Okay, these are my shadows, these are my heights. So everything needs to match up. Once I have this set up right, all I got to do is cross multiply. So I'm going to get 5h equals 72 times 3, 216, divide by 5, and h equals 43.2 feet. Pretty straightforward, pretty easy. It's all about the setup. The cross multiplying part is going to be nice and easy. How do I set this up? So I know this compares to this the same way equals the way this compares to this. And you need to be consistent. If you would have said 5 compares to 72 the same way h compares to 3, that would be wrong. You have to go the same direction. So you could have gone the other way. You could have said 72 over 5 equals h over 3, and it would work. Okay, but you have to be consistent. So I went from here to here. On my other side, I have to go from here to here. They need to match up. So we'll flip it over, and let's do this last one. So 2 rectangles are similar. Because of that, we can set up proportions to solve for some missing sides. Use a proportion to find the value of x, and then we're going to do some extra with it. So when I set this up, you're going to just match up the sides that are corresponding. So x matches 14, x plus 6 matches 18. So x matches 14. That relationship has to equal this relationship. Now, when I set this one up, I went from left to right in terms of the shapes. So I need to do the same thing here. So x plus 6 over 18. Once I've got it set up, I'm going to cross multiply. So we're going to have 18x equals, put the number on the outside and distribute it. So 14 times x plus 6. We're going to distribute here. So 14 times x is 14x. 14 times 6 is 84. You've got an x on both sides. Let's get rid of one of them. It's always best to get rid of the smaller one if you can. So 4x equals 84. Divide by 4. And x equals 21. So I've answered the initial question. I found out what the value of x was. Now let's see. They want us to find the perimeter of the larger rectangle. So if you come over here, if you look at the larger rectangle, this side's x, which means that one is 2, which means those are both 21 because it's x. So I'm going to have 21 plus these two sides. So again, if x is 21, 21 plus 6 is 27. So if you want, you could put this whole thing as 21 plus 6, like that, plus another 21 plus 6. It's a little excessive, though. You don't need to write it that way. You could just put 21 plus 27 plus 27. Nothing wrong with that. Okay, for a total of 96. Now, we don't have feet, inches, anything like that. It's just 96 something, 96 units of something. And then for your area is just base times height. So your base and your height are your 27 and your 21. It doesn't matter which one you call the base and the height, because depending which way you flip this, you may change your mind which one's which. But you're multiplying, so order doesn't matter. So 27 times 21, our area is 567 something squared.